in geometry, there are certain things that we just define as being the case. So in order to do geometry, we need certain rules that we can follow. And then in this class, there's a very specific set of rules that will outline something called Euclidean geometry, which is geometry on a flat surface. That's all we're going to do in here, but we could define things differently and get different kinds of geometries. But in this class, we've got some very specific things we're going to define. All right, so first we're going to start with a point. A point has 0 dimensions. So think about dimensions as the number of ways that you can move. So if your entire universe is just one point, say point A right here, there's no movement allowed. You can't move anywhere without moving off of point A. So there are 0 dimensions there. There's 0 ways that you can move if you're on point A. And in geometry, we're going to name points with capital letters. So we will name this point A with capital letter. A line has 1 dimension. So if you are on a straight line, you can move in one fundamental direction. So you can move, say, along this way. And of course, you can move back the other way. But really, you're just moving the reverse of the way you just moved. So there's really one fundamental direction that you can move on a line. So if I try to move, say, if I'm on point B and I try to move this way, now I've moved off the line. So there's really only one fundamental direction that you can move on a line. So it has 1 dimension. Now, since a line can extend infinitely in both directions, we use these little arrows at the end of the line just to indicate that it's extending on forever in those directions. There's a few ways that we can name a line. One way we can name it is just to write down 2 points that are on the line and then draw a little line above it. We can switch those points around too and get the exact same thing. So line AB is really the same thing as line BA. Another way that we name lines in geometry is by using a lowercase letter. So this M right here, that lowercase m, we can use that to call this line M. Now a plane is a flat surface, a flat 2-dimensional surface. So you could think of the screen that you're looking at. The screen is a 2-dimensional surface. We can move up and down, and we can move left and right. There's kind of 2 fundamental directions that we can move. Now you might be thinking, well, but you can move, say, this way, diagonally. But if you look at that, really, you're just moving a little bit to the right and a little bit up if you're moving diagonally. So it's not really a new direction. But up versus sideways is definitely totally different directions. So we have kind of 2 directions that we can move on this 2-dimensional screen, on this 2-dimensional plane. You can also think of a plane being something like a floor or a wall or a ceiling, some flat 2-dimensional surface. Now we need 3 points in order to define a plane. So if we look at this plane, this is a representation of a plane boxed here. So we have 3 points on there, A, B, and C, and we need at least those 3 points to define a plane. If you imagine taking a book or some hard flat surface and trying to balance it on 1 point, so say if you just stick out your finger and try to balance it on that, it wouldn't be able to balance on there. Even if you took 2 fingers and put the plane or the book or whatever you have on top of 2 fingers, it still would not be able to balance. You could still tip the plane around. But if you use 3 fingers, well, now you've got something that's steady. So now that book cannot move if you use 3 fingers to hold it up. So that's why we need at least 3 points to define a plane. Now for the name of a plane, we just write down the 3 points, or I suppose we should say plane ABC. Let's look at the idea of collinear points. So the word collinear has linear in it, so linear means line. And then think of like co-pilot or cooperate. So if you take a look at the word cooperate, you're operating together. So co means together. Co-pilots are people who pilot a plane together. So collinear points are points that are together on a line. So points that lie on the same line. And then coplanar points, very similarly, lines that are together on the same plane. And then we can, of course, have non-collinear points and non-coplanar points. So for example, if we have points A and B on a line, we could have point C over here. These 3 points are not collinear because they are not all on the same line. If we put point D here on the line though, you can see that points A, B, and D are collinear. They are all on the same line. C is not though, so C is not collinear. All right, let's look at coplanar then. So coplanar, well, if we look at all 4 of these points I just drew, they are all 4 coplanar points because they're all on your screen. But if you imagine taking some point that's on the ceiling, well, that point on the ceiling is not on your screen. So since your screen is a plane and that point is not on that plane, that point would not be coplanar with A, B, C, and D. Example 1. Give 2 other names for line PQ and for plane R. Well, first of all, let's look at the picture on the right because it looks a bit confusing. So again, we have this plane here. And imagine that extending infinitely in all directions, but we've got it represented by something here in the picture. Now, one of these lines is lying on the actual plane. So if we look at that blue line, imagine the plane being like a piece of paper, and then you draw that blue line on the piece of paper. So that lies on the plane. This one here, the red one, is sticking up out of the paper. So if you imagine the paper being, say, flat on a desk, horizontal, this red line is sticking straight up into the air, coming out of the plane, going right through, so imagine it poking through the piece of paper, going right through the piece of paper, going up and down, whereas the plane is horizontal. So the blue line is on the plane. You could draw it on the piece of paper. The red line is poking through the plane, going up and down. Now the reason why this picture looks a bit confusing is because this is really a 3-dimensional object. If we have a plane with something sticking through it, that's a 3-dimensional object, but your screen here is 2-dimensional. And so when we try to take a 3-dimensional object and represent it in 2 dimensions, we lose information and it doesn't quite look right. So that's why this picture is a bit hard to tell. But unfortunately, we don't have the technology for making holograms, so we can't do that. All right, let's look at names for line PQ. So that's this red line right here. Well, one thing we could do is we could just switch the Q and the P around. That's really the same line. Another thing that we could do is we could name it with the lowercase letter right here, line N. All right, so if we want another name for plane R, so you can see this R right here, that's naming this plane. Well, we can name a plane with points as well. So we need at least 3 points. So what we want to do is name 3 points that are on this plane. So for example, we could not use point Q because Q is above the plane, it's not on the plane. Also, we don't want to use M because M is not a point, M is a name for the line. So what we'd have to do is choose either V, S, P, or T. We're going to have to use some combination of those. So we could say plane V, S, P. That's one thing we could say. Or we could say plane, let's see. I didn't use T last time, so let's use T. T, P, and V, that would work. And there's other combinations you could use as well, but you just need 3 points on that plane. All right, part B, 3 points that are collinear, so 3 points that are all on the same line. Well, looking here at S, P, and T, all 3 of those are on the same line. So 3 collinear points would be S, P, and T. Now V would not be collinear with those because they are not on V is not on the same line. If we want 4 points that are coplanar, so it'd be 4 points that are all on the same plane. Again, we can't use Q here because Q is not on the plane. Q is above the plane. Also, remember, M is the name of the line. That's not a point, so we can't use that. R also is the name of the plane, not a point, so we can't use that. So our only options for points are V, S, P, and T. And actually, those 4 points are all coplanar. So those are the 4 points that's really the only option that we have. Those 4 points are all on the same plane. So that's what we've got to use, V, S, P, and T. Part D says name a point that is not coplanar with points Q, S, and T. Not coplanar with Q, S, and T. So for this, we're going to have to kind of think about what this picture looks like a bit. So again, Q, S, and T, those are the 3 points that we're looking at. Now remember, Q is not on the plane that's pictured there. So what we'd have to do then is have to think of a different plane, another plane, kind of sticking up vertically. So imagine taking another sheet of paper and resting it vertically on top of that sheet of paper so that it goes through all points S, T, and Q. Well, if we did that, if we had another piece of paper sticking up vertically, hitting the plane just at the edge of the piece of paper, then V, well, V would not be on that piece of paper. So V is not coplanar with Q, S, and T. All right, let's look at segments. So segment is basically just a chunk of a line. So we take a line that extends infinitely in both directions and just chop off pieces of it. And the way that we write this is we write the two endpoints of the line, and then we draw a segment, or I should say the two endpoints of the line segment, and then we draw a segment above it. So remember before when we had a line, we would just write 2 points on the line and then draw a line above it. Well, if we have a segment, we just write 2 points on the segment and then draw a segment above it. And again, the same rule applies that we could switch it around and call it BA as well. Now, if we do a mixture of, say, a segment and a ray, so we have one side where it ends and one side where it continues, this is called a ray. And we're going to name that with the 2 points, and then we have an arrow above it, so where one end, the left end, is not continuing on forever, and the right end is continuing on forever. Now we could write this a different way too. So line, or say ray AB could be written like that. It could also be written like this, but if we do that, the arrow needs to go in the opposite direction. And that's because for this first one, the ray starts here at A and then points through towards B. So on our notation, with these two here, the arrow needs to start at A and point through towards B. If we have the ray going the other direction, where it starts at B and then points through towards A, well, we could name that like this, where the ray starts at B and points through towards A. Or if we switch the letters around, then we've also got to switch the arrow around so that it starts at B and points through towards A. The word between in geometry has a very specific meaning that is not exactly what you would use in normal conversation. So the word between is reserved for points that are collinear. So if we've got point A and B here, and we say that C is between them, that would not mean, so say for example, if we had a point right there, the green one, that is not between A and C. Kind of looks like it's physically between A and C, but it's not collinear with A and C, or A and B. So we say that it is not between. This point right here, the point on the line, that one is between A and B. All right, let's go to example 2. Give another example, another name for segment, GH. Well, for segments, really the only way we could rename that is by switching the letters around. So we could call it segment HG. Part B says name all rays with endpoint J. So J right there, starting there and going this way, we could have that. We would have to call that ray JG, with the arrow starting at J and pointing towards G. We could have the ray going like this. So that starts at J and then points through F. So that would be written like that. We could have it start here at J and point through towards H. So we would call that JH with the arrow pointing from left to right. And then last, we could have it starting here at J pointing through E. So we would call that JE with the ray starting at J and pointing through towards E. Opposite rays are rays that have the same endpoint but go in opposite directions. So for example, the blue one and the black one on there, so JF and JE, those are opposite rays because they both start at J and then they point in exactly opposite directions. So we could say that ray JE and ray, let's see, what's the other one, F, JF. So that's a pair of opposite rays. The other pair of opposite rays here is the green one and the red one. So ray JG and ray JH. Those are also opposite rays. In geometry, when we're looking at the intersection of objects, we're talking about the points that they have in common. So, for example, with these lines here, these lines intersect at one point. That point is point J. So when lines intersect, they're just going to intersect at one point. Now, we could also have more than one point if we have different objects other than lines. So, for example, if we look at the walls of a room, so if you look at two walls in a room meeting at a corner, they meet on a line. So there's not just one point. You could actually draw, if you were allowed to draw on the walls, you could actually draw a line, take a marker and draw a line down where those two walls meet. Or you could talk about where the ceiling meets the wall or where the floor meets the wall. You can draw a line along that intersection. So we've got a line of intersection, a whole bunch of points there that are all the intersection of these two walls, or these two, the wall or the ceiling, or the wall or the floor. These are all planes that are intersecting on a line.